Okay. Hubble's law and Big Bang theory. When we observe uh, things in the sky, we find that every object is moving away from us. Last time we were discussing redshift. Redshift means that wavelength of wavelength that we receive from any star is more than the wavelength that is actually being produced on it. And why is that? If you are familiar with the concept of Doppler's effect, when something recedes away from you, we something is receding away, it is moving away from you. You will have a lack of or decrease in frequency. So light is also a wave. It undergoes the Doppler's effect as well. And when light undergoes a Doppler's effect, we receive a wavelength which is larger than actually produced on the surface of the star. Now, this is a very simple example. For example, if this is the emission spectrum for a star, but when we receive it on Earth, this is what we receive. So I hope you can see that all of the lines have been shifted this way. And then this is lambda max. So what is happening is wavelength is increasing. There is an increase in the wavelength. So when wavelength has increased, it has shown that object is moving away from us. Okay. This is called Doppler's effect. Now, if something approaches you, here we go, redshift. If luminous object moves away, if luminous object moves away, and blue shift if luminous object moves towards. If any luminous object moves towards you, you will be receiving a wavelength that is shorter than actually produced. That is called blue shift. And if something is moving away from you, you will receive a wavelength which is bigger than actually produced. That is called redshift. Now, mostly things are moving away from you, but there are some examples where you can also observe blue shift. For example, there is a binary star, binary star. You observe that star from the Earth. So this is an observer. And binary star is a pair of stars cycling one another. Okay, so these stars are cycling one another. So for some pairs of binary stars, when we observe them, one star is moving towards you and one star is moving away from you. So in that case, from one star, there is a there is a possibility of you receiving a wavelength which is shorter than uh, actually produced. Okay. So binary stars, they have one example where we can observe a little bit of redshift, but everything else, whenever we observe, where they all are moving away or we are moving away from them, any one of these two is true. Either those luminous objects are moving away from us, or we are moving away from those luminous objects. In all observable universe, we always observe bodies moving away. What does that mean? First of all, how do you know how fast something is moving away? Now, remember, change of lambda over lambda equals to change of frequency over frequency equals to speed with which something is moving away or towards divided by c. And these are approximate relationships, but we can use them to find the.
Sir,
Yes.
सर ये आपने दो स्टार्स ड्रॉ किए हैं लेकिन आपने बाइनरी स्टार लिखा है तो ये दो डिफरेंट होते हैं या सेम होता है स्टार?
नहीं, सेम से तुम्हारा मतलब क्या है? सेम सर, ऑब्वियसली इट इज अ पेयर ऑफ स्टार, जिस तरह आपका जूतों का पेयर होता है। दोनों जूते सेम होते हैं या डिफरेंट
जी
होते हैं?
सही सही।
यानी in many ways they might be same, but in many ways they will be different. Like these are two stars, two masses moving around one another. ये मैंने एक क्वेश्चन भी कल शेयर किया था इस तरह का. Let me go there. Yes. These are the binary stars, and this is one. So this is how they are moving. One is of mass 1.6 into 10 to the power 39 kgs, and the other is 4.0 into 10 to the power 37 kgs. So it is not necessary that they have same mass.
Okay, sir.
So they will be binary stars. So if we observe them on one side, they show that the orbital time for the binary system is about 100 years. Okay, so, and one more thing is that they don't orbit one another. They both orbit around the same center, same uh, point they are moving about. Okay, in this case, I haven't read the question, so I actually know. But I think from the making of the question, it looks like that this would be the center about which both of the stars are moving with same time period. Okay. Now, so this is an example of blue shift and red shift. Uh, this the central one is unshifted. The upper one, everything's moving towards red. The lower one, everything's moving towards blue. And I think we have discussed all that. Now, change of lambda over lambda. Explain why the red shift leads to idea of universe expanding. If everything that we look at, everything that we observe is moving away, how is that possible? all observable universe is moving away. Only possibility is that whole universe is expanding. This whole universe is expanding. Other than what can explain everything moving away? Whether we observe distant galaxies or we observe distant stars or we observe binary stars, pulsars, supernovas, whatever we observe, everything is, is moving away. Okay? So that means that the whole universe is expanding. Now, here comes Hubble's law. What is Hubble's law? Hubble's law is that speed or rate of expansion is directly proportional to observable distance. Hmm? Speed is directly proportional to the distance. More the distance, like we see a universe, for example, this is us. This is a star. This is a star. This is a galaxy. This is another star. Okay. Now, they all will be observed to be moving away. They all are moving away. So when we observe them all moving away, what does that show? That shows that the universe is expanding, like everything is moving away from everything. So there, this distance is also increasing between them. Every distance is increasing. But there is one more thing. If we can actually observe the path that at which any any luminous object is moving, we can backtrack it and can find out where are they coming from. And this is another strange thing. So, number one, everything is moving away. And there is another thing that they all are moving away from a certain single point. So this is the idea of Big Bang. Okay. This was the idea of Big Bang, that we were just a single very high frequency photon. And then that photon converted into everything, or a pair of photons. Say. So some kind of interaction happened between them, and the whole universe and the space that the universe are in was was produced. Okay. So the bigger the distance any object has from this Big Bang point, the faster it is expanding.
सर यहाँ पे हमारी भी तो कोई स्पीड होगी ना, तो वो स्लो होती है क्या अगर
Listen,
रेडशिफ्ट आ रहे हैं तो?
चलो चलो ये देख लो, ये भी तो एक स्टार होगा ना यहाँ पे, जो बिग बैंग के करीब होगा। अपनी पोजीशन याद रखना, आप यहाँ पे हो से, दिस इज यू। ना ये स्टिकमैन जोन सा, ये तुम। So you are also in this expansion business. Who will be expanding faster, the star X or you?
Me.
Good. When you will observe star X, will you be moving away from star X or moving towards star X?
Away.
And when you observe star Y?
Towards.
No. Who will be expanding more, faster? Star Y or you?
Y.
And will you be observing it, like, will Y be coming towards you or moving away from you?
Away from you.
So see, whether you are closer to that point or away from your point, you are moving away from the rest of the things.
Say, sir.
So overall, the whole universe is expanding, and this is the proof, or not a proof. Nobody can prove Big Bang the way we prove things in physics. Like in physics, we only prove things if we can perform an experiment on it. So we did not, could not, or would not be able to perform a Big Bang, I guess, if we are lucky. Then we don't convert it into a law. That's why we will always be calling it a theory. And some part of the universe is expanding faster than speed of light. They at a certain distance, the expansion is so fast, and this is why we see the universe as black. Did you ever like bother why sky is black? Why not any other color? The thing is that is the part of universe which is expanding at a faster rate than the light can come to us. Like even if it is emitting light, light is coming towards us, but the source is moving away from us at a speed which is far more than speed of light. What happens? The light cannot reach us. So that's why the bigger part of the sky is black. Black actually means absence of light. Okay. So here is just for information, because we have done these things, that the temperature is proportional temperature is proportional to the color, the wavelength. Because if you remember, let me do it here. If we are receiving multiple wavelengths from a certain star, we will observe that which wavelength has the maximum intensity. Maximum intensity wavelength is directly proportional to 1 over temperature in Kelvin. Okay. So, see, this is almost red. This will be producing 3500. It is at a temperature of 3500 degrees Celsius. And look at this blue giant, I guess. Surface temperature is 33,000. So the wavelength is giving you an idea of now type of stars. Yellow dwarf star, red giant star, red supergiant star, blue giant star, and you know there is a problem. They cannot make it with the scale. Like if they make a red giant star to its scale, then there will be no space to draw a normal star, because the star like our sun will not have a diameter that can be fit on one pixel over there. So that's why these diagrams are not to scale. They're just showing colors, how the colors are different, but they're not showing you their sizes. Okay, now this is main sequence star. The different details are given over here. And these are not things that you need to remember. So just for your information, if you want to. Okay, these are the things which are to a scale kind of thing. Okay, so this is Earth. Okay? Because if he would have gone with the same scale as he was going earlier, then it won't be possible to fit everything in. So he has changed scale in diagram 2. 1, 2, 3 is showing Mercury, Mars, Venus, and Earth. So this is Mars. It is smaller, even smaller than Venus. No. According to syllabus, we have done everything. One was there's one formula left, I guess. That was for luminosity. It is sigma r. One formula is left. There we go. That luminosity equals to area sigma and temperature power 4. So because the area will always be in the form of a sphere, it will be 4 pi r square. So it will become luminosity equals to 4 pi sigma r square P4. This is a constant and its value will be given in the data booklet. I have another class waiting for me. So we will be doing some past paper questions tomorrow. These questions are already sent in the group. You can try them by yourself because it is hard to find these questions because this is a new topic. We will be looking at these questions for the first time. So one question was given to you in the mock, and now these are some other questions. You can try them, and we can discuss problems tomorrow. Okay.